Alright, right now what I ended up doing is now putting it together, put the flywheel on. I will do the wiring coming up next, going through the wiring. Right now I just want to make sure all the flywheel, it's a piece of wood, but it'll work for now. It's a little wobbly, but that's because of the wood itself is warped. And pretty much that's where I'm at on that particular design. Got everything together, everything's pretty straight. This is the stepper motor right here. This has multiple poles. I'll show you what it looks like. This is actually what's inside, and as you can see, there is magnets all the way around. The core itself is right there. It's a multi-core. So basically, it's a very expensive linear piston motor. Actually, a friend of mine gave me two of them for experiment. They're about $6,000 each. And they're no joke on that particular thing. So what I've ended up doing is basically making a generator out. Now on these linear pistons, how they actually work is when they spin, they actually push out this shaft, and that shaft comes in and out. So it's a linear stepper motor in general. So what I ended up doing, I'll show you why they're so unique. Because they have multiple poles, you don't have to turn this a lot of RPMs. This is a 12 volt light bulb right now, just to show you a little demo. And look, when I'm turning it, you can actually see the pulses of light. And I'm turning it very slowly. In fact, if I get in the middle and probably turn it, I can probably turn it even faster. And basically what you're doing is you're really let me see if I get a little crank on it. There you go. I'll do a little crank here. And now I'm turning it, as you can see. And look at my light bulb. So I can actually burn out that light bulb just a couple of RPMs, real easy on this. And gives you a pretty good idea. There you go. And that light bulb is really, that's a 12 volt light bulb. Actually it's 14 volt. And we are pulsing AC in this, so I would basically put a bridge rectifier on this to collect the DC, feed that back into the battery itself, and the battery is actually going to run a PWM high voltage discharge system using capacitors. And what we're going to do is use the very low amps but very high frequency, pumping up the capacitors to discharge into the coil itself to keep this baby running. And that's pretty much the simplicity of it. Now you probably wonder why I got all these holes here. I actually use this for a jig to actually wrap windings if I need to, but I figured I need a flywheel on this to get this thing going. As you can see, I mean, that's pretty bright stuff there. And pretty much that's where I'm at now. Also, you're probably wondering about the how am I actually be able to get a positioning sensor in it. I'll tell you, you can't get no better than that. This actually has a positioning sensor built in, and that's right here. So I'll be able to tap into this, my positioning of my crankshaft, to time the pulses. So it's pretty much built into the system. And that's another good thing about this particular unit, is that you actually do have all the parts in there. As you can see, this is the another piece of it. It actually has a positioning sensor in there that can easily be like a Hall effect, basically, in this particular unit. So I can actually control the amount of pulses and actually fire exactly where I want it to fire, if that makes sense. So that's a good thing too. And this is really sturdy. It's really heavy. It's probably getting almost up to about 70-80 pounds. So because these motors are not light. So pretty much that's the update. Things are looking good. I am generating power. That is a good thing. Now the key is, once I get this up to about 3,600 RPMs, this stuff can really put out some power. I'll show you a little chart right here. There you go, 3,000 RPMs, 460 volts at 5.3 amps. So it gives you a pretty good idea of the kind of power. So I'll talk to you later. Bye.